Hey, what's going on? Welcome to AngularAir. I'm your host, Justin Schwarzenberger, and on today's episode, we are talking intercomponent communication, as well as manageable and extensible objects. Should be pretty cool. We're looking forward to it. So let's say hi to our panelists, then we'll meet our guests and get on to our content. Joining us today, we have Alyssa. Alyssa, how's it going?
Hey, glad to be here.
And we have Austin. I'm trying to do this alphabetical thing. So A-L, A-U. I think I'm all right now. Austin, how's it going?
Good. How are you doing? When you said interconnected, I was thinking like intergalactic or something.
Yeah, we just needed to drop the beat and have a little. Yeah, that'd be yeah. I don't know, little Beastie Boys. All right, breaking the alphabetical order. We're going with Mike. Mike, how's it going?
I'm last. Not talking to you yet.
All right, so
I'm last.
So that's Mike. He's Mike. Bonnie, how's it going, Bonnie?
It's great. I'm super excited about our guest today. For once, I don't know him. Well, I didn't know him. I just met him like 10 minutes ago, but he's so cool. We're going to have fun. It's going to be a great show.
Should be good. Just a little backstory real quick on the alphabetical order. I had to go Bonnie last because, Bonnie likes to reveal our guests before I can announce her name. So, which always works.
I can't help it. I just get so excited.
Right.
But I didn't actually reveal the guest this time. I just said he was cool. Right. So there's still the mystery there. I'm getting better.
Awesome. Well, let's meet our guest, Bjorn. How's it going, Bjorn?
Hello. I'm happy to be here. Bjorn, I'm from the Netherlands, 29 years old, and really enjoying working with Angular the last couple of years. So happy to be on the show for first time.
Awesome.
29. That's like a grandpa in JavaScript land.
Yeah, you say so, right?
I don't want to hear that. No, it's 29. Wow, that was a while ago.
This is why we moved to TypeScript instead of sticking with JavaScript all the time.
So that you feel a little
more under control.
Yeah.
For sure. All right, so we've got kind of two topics today, right? We're going to dive into intercomponent communication first. So you want to get us started there?
Sure thing. Let's go. Let me sweep. And is that all visible? It should be.
I told you he was cool.
Well, intercomponent communication, or as you might use it on a daily basis, is how components communicate between each other using the usual suspects, like the input, the output, and services. And what I really want to talk on here is smart versus dumb components, or how I like to call them smart versus simple components, but they're all basically the same. You have components that...
Brocky is the dumb component one.
Sorry, repeat that?
I said Brocky is the dumb component one of the group.
And Austin is the mean one of the group, just so you know.
So
I didn't know you had a component style going here.
We have a limited component staff. I, for one, enjoy the smart and simple or decision presentation, avoiding the dumb comment.
Yeah, I feel dumb has a bad connotation to it as well. Yeah, it's not stupid.
In that as well.
Yeah. So I usually call them smart versus simple, or you could go logic versus pure if you're into that type of thing. But yeah, basically, the intercomponent communication is important when you have smart components that basically take care of your what the logic of your application is trying to do, and your presentation or simple components basically represent your data or have some interaction with your user that you can easily, if you do it well, reuse throughout your application without too much of a hassle.
What would be an example of like a smart or a dumb component?
A smart component would be basically where you retrieve your data or handle off the user events to send them off to a server, or to persist some data or to add new things. Basically, the component that composes all of your simple components in that sense. So basically, we're going to stick with a to-do example in the next topic, so I'm going to use them already. The actual component that does to-dos, or basically shows the to-dos, is considered a simple one, just a list, and has maybe a button that you would interact with. And the smart component would actually listen to these events and handle them for you, and retrieve the data as you go, of course.
So would a smart component be something that has like state management with it as well?
Oh, yes.
I could not resist, guys.
Yeah. You would. I would definitely opt for state management in the smart component if we can. Yeah, for sure.
And you know, dry component is something that I hear a lot. What's the difference between a dry component and a dumb component?
Well, you would say that a dry component, as don't repeat yourself, would be a dumb component. If it's composed or assembled well, then you can reuse it without having to rewrite much code, or without duplicating yourself, basically. So you can just stick it in a module and use it where you need. So you would say that they are very comparable.
Rocky, you're probably a dry component then.
I got nothing there, but I will add my
bad jokes just keep up today. I'm feeling a little sassy.
I can tell. The way I tend to think about the whole thing about the different two different styles of components or types of components is like an orchestra versus a musician. So the yeah, I got a finger away from Austin. Is that the musician essentially is the presentation / dumb component in that, hey, I play what I am told and respond to what the conductor is telling me, and the conductor is the smart component that knows how or what music to play and where to go get the data.
Lovely analogy. I like it.
Thank you. I had to redeem myself after Austin insulted me.
I can understand. If he throws too much sass, then just hit back at him, right? Anyway, continuing. So in the day-to-day basis, most people will be using the input and output. So is there anything wrong with that? Absolutely not. Most cases, this will be perfect for your regular needs. Input and output are excellent. But there are cases or situations where you might not really want to go with specifically output, since it has its limitations, so we'll get to that. But I don't want to overshadow that or like overstate that input and output are terrible choices. No, they're excellent choices, and if you can use them and they work for your situation, just do it. That's the best. But we're going to explore a couple of alternatives to just using an output. I also put services in the first slide. But services may not be great for simple components. There are situations, of course, where you could argue that a service that is very tightly integrated with your simple or presentation component, and as a module you can reuse them, that's fine. I would honestly say that's a very good solution if you could do that. But if you have very service application-specific services that you need to reuse in your simple component, you might be facing a challenge in the long run, especially in considering the dry part. Then the reusability just goes down if your service is very application or logic specific. So it's something to keep in mind when you're designing your components or splitting them up into separate pieces of logic. So using services in simple components might tightly couple your simple component to your applications, which is something you should maybe try to avoid if that doesn't work out for you. But the main issue with output that might want to drive you to look into alternatives is this little thing here. Is that well readable for everybody? Didn't get to test that, so hope it's fine.
Yeah, I think it's
good to me.
A little small, but I mean, if you have a way to enlarge it, yeah. But if not, I think it's fine.
Probably do. Nope, doesn't respond to that, unfortunately. I'll just talk over quickly what we see then. We have a little, app child, so that's insinuating a child component that has a thing output, and basically you have to handle your events that are outputted by the simple component. So you have this little handle function everywhere over your presentation or your smarter components. And as I said, most of the cases this is fine. You need to handle these things off. But what we kind of like sometimes, especially working with Angular that relies heavily on RxJS, is that you might want to get a stream of these outputs. And unfortunately, and I'm kind of wishful thinking, hoping that they will make that a feature in the future. But as of now, it's just not possible to just bind your output to an observable. Or is there? There's an alternative way right now without putting a subject directly in your own component. Sorry, yeah.
Sorry to interrupt, but
go ahead.
Aren't outputs just like a primitive observable?
Outputs are event emitters by default. You could go for a subject if you want, and the event emitters in Angular are subjects technically.
Yeah, under the hood, isn't an event emitter a subject?
Yeah, it is. Yeah.
Basically, but the one thing you've missed there, Austin, is that he's talking about the consuming of the events, not the actual events themselves.
Exactly. The outputs that you use in the simple component that you output are event emitters that are subjects, but let's just call them event emitters right now. On the parent component or the smarter component that is consuming that, you can't directly, without cheating, basically get that same event emitter inside and use that as an observable. So you'll have to find a way around it. Does that satisfy your question there?
I'm getting a big kick out of you. Don't listen to him because I like it. You're like, yeah, you can't do that yet. And you go, or can you?
Yeah.
I know. Tell us the alternative way.
Right?
I have two alternative ways.
Let's play a game. Answer every question I have with a question.
Yeah.
I forgot to mention, Austin, that we have these two topics that we're trying to get through. So we're trying to kind of get through this first one, fairly quickly to get to the next one. So
if you want to give me a hard time on the TypeScript part, I'm fine with that. So
we're going to let Mike handle Austin muting, and then you can just blow through the rest. Austin, he's got a lot to cover.
All right, so alternative way.
So I'll speed it up then. I mean, I can speak really fast if I want. So the alternative way is that you add one of the event emitters that you would usually have on your outputs on your simple components. You put one on your parent component, and you make it public, because else your strict compiler will yell at you and dislike you. But one of the things you can do in your HTML, where you firstly put the simple component and usually bind it, you can just do an emit there. And all of a sudden, you have yourself an observable to work with in your component. Pros is that the positive thing here is that your simple component is still as simple. Nothing has changed there. It still just does an output. It still only has one emitter. And if you were to use that same component elsewhere in your application, you could just consume it the way you have been doing it already, because this is just a cheat basically on your parent component. The con is that you have an additional event emitter to take care of. So basically another subject and potential memory leak if you forget to unsubscribe, basically, in your components that might give you trouble. But it does give you the power of Rx. Oh, my bad. You could also, and this is basically touching on the event emitter versus subject, they are basically the same. You could just use a regular subject or even go crazy and do a replay subject if there's something you want to do, of course. The methods don't really change here. But the point is that you get the power of Rx.
So I have a question on that.
Sure.
To see if I've got it correctly here. So really what's happening here is in this parent component, we've reduced the functions, methods that we have to create to handle the different events from the different children, right? Or the presentation. So like you have app child here, let's say we had several different ones and they all had events outputs, right? And we need to wire up to them. We would be just using child events.emit for all of those children, right?
That's a fantastic suggestion, actually. I tried to keep it simple here. We just have one child right now, but if you have, if you could, I mean, and that's just the TypeScript guy in me coming up. Like, if you have the events of coming of all these child components are predictable in the sense that they match, because you will have to respond differently to different type of events. You could go with multiple event emitters that you would emit the correct ones. So you have multiple streams of different events coming in. You could merge those, or you could basically join those to have one stream coming out, or split them up separately, whatever you want. I mean, we are using the power of Rx at that point, and you're not just locked into having a single callback function for each and every of your outputs. So yes, you could go crazy with that. I tried to keep it simple here, but I think there's a lot of possibilities that we haven't even explored in this topic now.
Okay, cool. Thanks.
Yeah. So as I said, the negative side of having this is that you have another event emitter to take care of. In addition, that you are exposing an event emitter or a subject publicly. So basically, you might be theoretically exposing its API to other components, and that is considered to be not the best of practices. So it's something to be very aware of when you're doing this. Yet another alternative way, and I find this one to be the dirtiest, but I'll let you as the panel decide which one you like better. But this has its pros and cons, of course, as well. instead of handling the output directly, we give it a child. And this is, I think, most of you would already be knowing what's coming up here. Yeah. You give it a child, and you could do it either this way, or you have two ways of doing this, basically. You get yourself a view child going on. And on that child component, you can call directly the thing, which is then the output event emitter on that subject or on that component there. And the pros here, well, you have one event emitter, and it's the same one on the simple component that is already being used if you reuse it. So you are not adding additional potential subjects or event emitters to your already possibly complicated architecture. Another good thing here is that you're not exposing another event emitter. The big no-nos here is that you are less explicit on your HTML. Like, somebody else reading this was probably not going to know that there's an output here that's not being used, or you might be wondering, why is that output not being used? Because you're not explicitly communicating in the HTML that you are using an output as an observable here, which with the other event emitter solution you do. So the HTML becomes less readable. And its intention, therefore, is less explicitly defined, which we would consider a good thing to do. And another very bad thing is that you are exposing directly an event emitter or a subject from the child component, from the simple component, to the outside world by using a view child. You can always, of course, do this, but we're really abusing it right here. And I would say that makes it quite dirty. But we still have the power of Rx, and we can fix that downside if we want. And this is where it gets really, really cheaty. If we do the same thing we had, this is the child component we've been referring to all the time. We have our output of thing with an event emitter, and we have a getThing function, which is public, which returns this .thing as an observable. And you could already have a function like this in your simple component to use the outputs to trigger other things. You know, a deselect all button might be internally used in the simple component as well. And you might want to listen to events that come off that. So you might already have a function like this in your application or in your component as this. And on the parent component, you can then do this.childComponent.getThing, which the only thing that fixes, it has most of the cons and pros from the previous solution. The only thing that it fixes here is that you're not exposing an event emitter from a child component to the outside world directly. You're basically securing it that way. And that also gives you the power of Rx here. So in conclusion, input and output are still excellent solutions. When you can and want to use them, just use them. Services are fine, but you got to be very conscious about your dependencies and how you manage that. And in case you want to use the power of RxJS, you may have to look for alternatives. There's multiple ways to do that, but they all have their downsides and might feel a little bit cheaty until the Angular team decides to actually implement this as a full feature. Thank you so far. Any questions that may have arisen that we haven't already discussed?
I have one.
Go for it.
It's brought up in the chat by Chaos Monster. So Angular on the Angular repo is issue 13248. And what it does is, or what it speculates and is proposing, is the idea of being able to
cold streams.
Yes, listen to the events as observables directly.
That would be perfect.
Having to go with the subject. So it's basically another alternative.
Oh, really?
Once it gets implemented. It's still an open issue for now, but it is something that's proposed and hopefully will make its way into the framework.
Well, yeah, Chaos Monster, he's pretty smart.
Well, that's fantastic. I've noted down the number. I'll definitely take a look after. So thank you for that.
No problem. I'll send you a link just to make it a little bit easier for you.
Thank you so much.
Thanks, Martin.
Yeah, it's real interesting how in the Angular space, there's so many different ways to accomplish something that you're planning on doing, right? And I think that's one of the big challenges that arises is, which do you pick to go with, right? What do you want? How do you roll? And then if you pick something and you're like, okay, this path is right, this code structure is right, this methodology is working, and then you add another feature, all of a sudden that may not be ideal for that as well. And so we end up flexing and fixing those things. It's an interesting thing that I see come up a lot.
Yeah, absolutely.
There's an easy fix for that. Don't scale.
Yeah, just stop adding things, Justin, maybe? No.
What do you mean your client wants new features? What's wrong with you?
Maybe the app is done already. Yeah, just ship it. Be done with it.
I
Don't
got
need any support there.
That's it. That's all you get.
Yeah, that's what you get. Any other questions, maybe from chat? Or did you come to a conclusion on which one do you find the most dirty or maybe like the best?
One quick question. Trying to remember. Sure. Hold on. We're going back to the first option. Was that internalizing the subject and essentially just having an event listener that's a function that would then internally inside of the parent component emit on a private subject within there? This way there is no bleed of potentially exposing a subject externally to the component?
If we could make it private, that would have been perfect, but the strict Angular compiler doesn't like it when you use a private variable in your HTML. So no, it has to be public, so you are exposing it.
Correct. Yes, I agree if you were going to be using that within your template. But if maybe on the click handler, I just have a function called click handler, and then inside that function of my class is when I would emit on an internal subject.
That's basically the same thing. Yeah, I like the. I personally like the doing it by the event emitter better because it just cleans up your smart component by not having a function that basically just emits on a subject. But yeah, I think that's a matter of preference. That's basically the same. You could make it private then and not expose it as much, for sure. Yeah.
Cool. I cut you off, Austin. You may proceed.
Oh, I forgot what I was going to say. Oh, I remember now. So I never have an opinion or anything. But my 2 cents on this is the child implementation one tightly couples where you're getting a reference, tightly couples the parent and the child together. Whereas if it were just emitting an event, anything could be emitting that event. And really, you're just subscribing in a wonderful, observable rainbow world.
Do you? I see how the parent component gets tightly coupled to the child, which is, I think, inadvertently in every implementation of a simple component where you just have to listen or work with what's being exposed, basically. I don't really see directly how the second implementation tightly couples the child to the parent, as it's basically returning or publicly advertising the same already used output event emitter as an observable, which is nothing crazy in that sense.
Rather than when you're getting a reference, right? You're directly referencing that child and your parent, and I would see that as less than ideal than just like a child emitting events, because then multiple things could all be emitting the same event, and it couples it a little less loosely.
If you're referring to specifically having a function that would return the observable instead of just getting the actual event emitter and turning that into observable on the parent side, then yeah, I kind of agree there. That's true. But you could still, as I mentioned during the presentation, you could still have already a function that returns the event emitter as an observable and not really change anything. You are more tightly coupling the parent to the child for sure, yeah. But that's what all these Gs have in common. They're very well. The first one is a little less in that sense, but it's still you're still always more tightly coupling to your child component because you are relying on a specific output name to begin with, and which you also do when using regular output callbacks. If the name changes, you have to revisit your component, basically.
Yeah.
And this is really interesting, but don't forget he has another whole section.
Thank you, Bonnie. Thank you, Bonnie. I was thinking that. I was ending. Love you.
Love you too.
It's great having a discussion though, because advertising cheats never a good thing. So I'm all for.
Cool.
Do you want to move?
Yeah.
Yes.
All right, sure. Then I think we have everything ready. So the second topic here, manageable and extendable objects. I'll just quickly start it off simply by saying that I'm still working and really researching this topic, as it's very interesting on the one side if you're interested in working with TypeScript more deeply. But what I have here in the presentation are very simple basics, are basically some examples on a lower, more introductionary level, to show the differences and to see where we can go, where we can take it. So I have some experiments in the repository. I think the link's in here at some point. You can check it out if you want. And we are working on more experiments, and I'm sure this topic's gonna change over time. So let's just get into it. Wait, I should probably introduce it properly. So manageable and extendable objects is basically the talk about our objects in our application where you try to represent your model, your domain. And usually this consists out of classes versus interfaces. You see this a lot with people with a back-end background coming into the front end for the first time. Or, I mean, I've seen it a lot when in different and several projects where classes were heavily used because they are very reliable and they are very compiler friendly in that sense. We are talking here about classes that you want to use when you expect your front-end part or your app basically to generate instances. And interfaces work best when they are served from an external source. So basically, interfaces work best when your external source has a representation and you wrap it into an interface, and then the front-end world just rolls with that, basically. So we have an example of a to-do class. Very simple right now, you would say. It has a read-only with an ID of a number. It could be a string, of course. That depends on our architecture and what we're trying to do here. It has a read-only title, which is also a string. And a public is checked of a Boolean. Doesn't have an access modifier. Else, if you don't have an access modifier, then the class won't be assigning it for you. So after compilation, you will lose that information.
That is my favorite feature about TypeScript.
Yeah, it's pretty good, right? Automatic assignment. This makes the classes a lot more easier to work with. Yeah, totally agree. So this class right now looks fine, right? And it probably works well for the time being. Now we get the thing that most developers like or hate. Nothing is constant as change. So the requirements change. Things change. The ID has to be a string now. We should have been using UIDs from the start. We have children now in this thing. So it needs to have children now, which are apparently optional, which is a sub of its own, and a potential area of its own. And we've added a little bit of class-specific logic, so basically type-specific logic here, which makes sense. I mean, that's what classes are really good for, to have your logic close to your actual data model. So this starts to hurt, of course. You might have a representation of something like this in your HTML, but I think the HTML part here is a little less interesting. It's more about the data model itself. So now if you were using this in your application and you had a couple of simple components, maybe implementing some versions of these, you have a smart component, maybe generating new to-do instances as you send them off to the server for processing and stuff like that. And you have to revisit all these spots right now because your model has changed. Things might come and go. The IDs are now all strings, so you have to do something with that. Maybe you want, when you're creating one, you want the server to assign an ID instead of your front end. So what are you doing with that? This is where classes start to hurt a little bit. Let's talk about the good parts of a class first, though, because you get perfect type completion. Basically, classes, when you open them up, you say new to do. TypeScript can't wait to start helping you with what it requires. It wants an ID, wants a name, maybe wants a Boolean to indicate if it's turned on or off, all that good stuff. It's a good idea as well to try and keep only one domain entity instead of multiple, although we'll see that might go a little different way here. But it's a good principle to have one class with some logic on it to work with, basically. And your objects, that's a good thing about the classes. Objects are still recognizable on runtime. So after compilation, you will get something like a little to-do prefix before the actual object. So you can recognize that you have an array of 20 objects or of 20 to-dos instead of 20 anonymous objects, which is nice. Although, quick caveat, if you run your production build and you have some minification going on, then there's a good chance that the nice class name of to-do has been renamed to the letter E. something good, something bad, I guess. But in theory, they are, especially in dev mode, they are just recognizable on runtime. That's good for debugging. And compile errors. People hate them, people love them. I see compile errors as the compiler trying to help me and point out my silly mistakes. I am happy with compile errors. But classes really help with compile errors. If you change your class, then your entire application will be full of compile errors, and that is a good indication that everything that where you use it basically gives you a list to check everything that you have used it. Of course, when there's good parts, there might be a couple bad parts as well. The bad parts of a class are that extendability is quite limited without breaking your existing code. So when you have your class spread out through the application everywhere where it hits the model, basically, you change your constructor and everything breaks. You have to revisit everything. Makes it a little bit hard to extend on without having to revisit or redo entire parts of your existing code base. To transform your external data that comes from a server, you'll have to either use a map or do some trickery with that to get the actual benefits of having a class. So you can use these internal logic. You can use the internal logic, or you can actually see the runtime name of the object. So you have to transform it in order for that to work. Just assigning it doesn't really do it after compilation. And of course, the compile errors are also a bad thing, especially in more complex situations where it's not as simple as one to-do app with maybe a page or two. If you have a big domain with a lot of different objects that might rely on each other, one change can maybe break half of your system, and you'll be busy for hours or days even to revisit everything and refactor it so it works back. So that might be compilers might start to hurt there in that sense. And long constructors are very painful. Even T.S. Lynch says so. They put the maximum at 7 by default. I tend to put it back to 5 or 6 because that's my first warning sign that I might be using classes wrong here. But long constructors are painful. If you have one, you'll know why.
And the 7 to the arguments parameters.
Sorry, what?
The number 7 referring to.
Yeah. Oh, yeah. Of course. Yeah. Number 7 is the amount of arguments in your constructor. In that sense, yeah.
I just learned that last week from Juan Herrera, and I love it.
Oh, really? Nice. Mm-hmm. I ran into it by in a project, and I was happy that T.S. Lynch had a real rule for that. So classes are terrible. Well, no, they are quite useful. Just I would say don't abuse them. They're perfect for limited and specifically scoped pieces of code. So basically, when you have small pieces, let's say you want to have a class that helps you generate your new to-dos to be sent off to your server. I think if you go back 10 years into the past, they would call that DTOs everywhere. Not sure if that's still a thing really in the Angular world. I haven't run much into them in the wild, but that's exactly a perfect example of what a class might be useful for to create your data transfer objects. So that's exactly the example. Like the creation of an object that is the minimum requirement to create a to-do would be an excellent choice for a class in that sense. And so it's simply, sorry, yeah.
Where do you draw the line between interfaces and classes and when to use each?
Well, I don't want to spoil too much of the rest of the presentation.
Oh, sorry.
And especially with the additional experiments and research that I've been doing the last few days.
You're such an overachiever, Austin.
I'm starting to move away from classes entirely, but you'll see that in the experiments if we get the time to revisit those maybe. So in simple use cases, like the service that actually takes care of posting it to a server could actually also be in charge of creating that exact object it needs. So it knows the contract that the server wants, might as well just hand it all the information and let it take care of that as well. I mean, that's a way to not have to deal with classes or deal with classes in a very specifically scoped limited piece in your architecture. So an example here, export a class. Just to create any to-do and let the assignment of the ID be done by the server, and the default state would be it's off. This would be sufficient to do so. And the service could look like this. You have your create new to-do, requires one of the type of to-do because that's your class, and it just sends that off maybe maybe returning the new ID for you if you want. Things you could do, of course. Or another way, when we talk about the services taking care of it, service just knows the contract, basically requires only a title, and it'll create the object to send off to the server. This might also bite you back in the future if you have a domain that's heavily under change. But this is a very valid solution in certain situations, of course. So why interfaces? And now we get to the bread and butter of the presentation, of course. As we said, it's useful when the data is external, like from an API or a service that you have, or from a JSON file maybe. So interfaces are very useful for that. The amount of painful compile errors you get when your contract changes is negated to a minimum, because the implementation of your interface usually doesn't reflect the directly actual creation of objects. Like, you don't have to manually assign that. You can just say, you are this interface right now, and be done with it. And because it's from an external data source, you might have contract issues if your objects don't match the actual pattern you're expecting. Interfaces are a lot easier to compose with, and especially to compose complex objects with. And we'll get an example of that in the presentation in a bit. And it makes your objects that you use in your app a lot more manageable and a lot easier to extend as well. So let's take the previous example of our to-do class we had. I put an I here. It's very old school, and the Angular style guide is really suggesting to consider not doing that anymore. They're not saying you can't, but I really don't like it. I did it here in this exact... oh, I see Austin has a comment here. Go for it.
I was tisking.
Oh, tisking. Yeah, you don't like the I, right? Yeah, no, I totally agree.
Very sharp of you.
It's very old school, as I said. But I had to do it here because I was building this entire presentation in one file, and my TypeScript compiler didn't like it when I had two types of to-dos next to each other. So I had to do it, and it kind of signifies an interface, but I really don't like it. But we're rolling for it now. I hope you'll forgive me. So your service might look something like this that retrieves your data. It just basically says, here's the URL, and oh, by the way, this is an array of to-dos, or we're going to call them to-dos from now on. And the observable is just returning an array of to-dos, and you're done. When the details change, you change them in one place only. Your interface is your one and only contract of the object representation in your application. The compile errors are only limited to hard-coded data that you may be using in your application, either the generation of new objects like the smart component would, although you could probably put that away in some other type of thing, maybe a class or something. But your compile errors are only limited to hard-coded data. So if you have like test data hard-coded somewhere in your application, and we've all done it, then that would break when you actually run your test, of course. And the Angular style guide actually recommends interfaces to be used as data models. So that's another plus why you should be using interfaces here. The type completion in usage is actually still pretty good, as I was actually surprised when I first started researching this. Because this is an interface, as you can see, slightly might not be very readable, but it says an I to do, and it just says it has an ID and is checked in a title. What do you want from me? The ID is a string. So that type completion was above par for my taste. And of course, when you start using TypeScript more advanced, you'll run in that TypeScript's actually really smart. So in hindsight, I should have known. But at the time, I was quite surprised. So we've made it a bit more manageable. But what about the extensibility we've been talking about? Interfaces grow a lot more easily, where classes start to bite you when they grow, and you'll have to revisit a lot of places. The interfaces can easily be composed by using more interface. So as your data model becomes more complex, as we have an example coming up, as your domain grows more complex, your interfaces can still be relatively small and reuse a lot of other interfaces without having to create complex functions to generate these separate objects, or create very complex classes that refer to each other and extend each other everywhere. So as your project goes, your domain model will usually grow as well with it, and interfaces really help you. So here we have an interface of a to-do, as we were talking about earlier. It has an ID, title, a status right now. That's new. We have apparently not. We've done away with the Boolean, so it's now just an unchecked in progress. It's done, or it might be late. The owner is a user, of which we have a separate interface, which has an ID, a name, an email, a last online date, and so on. You can imagine the amount of data that will come with a user if you want to use that. And the children are still there. They are to do now. As you can see, I dropped the I here in this case.
Bjorn?
Yeah.
Question. Do you have a recommendation on when to go with the type? You know, a type versus a field or something in your interface?
Yeah. Well, this one's. That's a good question. Yeah, interfaces and types are very comparable. I think there's a couple of things you can do with a type that you can't do with an interface, and that refers to type inheritance. But that's not in this presentation. It is the things that I've been researching on. So, yeah.
Type unions.
As well, yeah. This is called a union, I believe. What I have done here with the status, or is this? Yeah, that's a union.
But you can use with types. You can do strong unions between multiple different types.
I'm not sure if I understand.
A type that was like.
Yeah.
Type user.
Yeah.
Equal, and then I could say type admin, and then I could say type employee, and I could use them all together.
Exactly, and call it.
You can really do with interfaces, can you?
I'm honestly not sure. I think if you have multiple interfaces and you have a type on top of that, where you use where you union all these interfaces, that would work. I think so. I'm not sure where that line is, but I think that types have a couple of additional features that interfaces simply don't. But I'll have to look into that. I don't know what the exact line is where you would like objectively go for a type over an interface. Usually, when I can't do with an interface that I want to do, then I switch to type basically.
And what
I don't know when to use one or the other either. So
yeah.
And then what like in this case, the to-do status, a type versus an enum.
Yeah. Yeah. Well, enums refer to numbers in the end. This was just an example I whipped up. If you have numbers in your backend and you can easily make these like overlap, then surely you could bring in an enum for not a problem. And that's also very different from
type. As numbers. You can make enums as strings in TypeScript.
Yeah. Or as objects even, I think, and then assign them a number. So you could use an enum in that sense to do like a HTTP status code lookup table or something like that. So that's some interesting stuff you can do there for sure. Yeah, and that's all TypeScript features. So heavily looking into that.
Cool.
Moving on. We could even go more type safe, and this is where we get into the more interesting stuff. The first one is a little trick that a colleague of mine found. We have an export type of to-do ID that is a string and a union of an anonymous object with just two random words that are assigned. You could use anything here, but I like to keep them close to the domain we're working. And what this does is you can now assign in your interface of to-do that the ID has to be a to-do ID, and you could have functions that only accept to-do IDs. The good trick is you can even make it more strict. That's the more advanced stuff that I'm not going to go into here. But what you see here is that when we have a little piece of code and you have to get to-do details function that we described earlier that only accepts to-do ID, if you just pass it a regular string, as I do in the bottom, you get a type error saying that a string, or an empty string in this case, is not assignable to the type of to-do ID. Where the to-do item.id that we have casted as a to-do interface just works fine. Doesn't complain at all. So we use this now everywhere. And when you have like certain very files that look very much like each other, but you cast them in the right way by doing type intersections and stuff like that, you can actually prevent yourself from assigning an ID that isn't supposed to go anywhere in a function, which is really, really powerful, we've noticed. So you could even swap out classes for types, which is the thing that I've been researching, and that's probably way more coming up in this sense if we get the time, or I get the time to develop this a little bit. So here's the same thing that we have, the export type with the to-do ID. We have the interface of to-do where we again drop the I like it. And we have a type called new to-do, which picks from the to-do interface, picks the title and is checked, which will take the optional part of is checked. So is checked is an optional Boolean. It will take that with us, and it'll give us the option to create a new object on the fly. You might do this when you generate your new to-dos to send them off to your service. You give it a title that you cast as a to-do ID, else it will give you an error. And you set your is checked in this case, but it's still optional. And this way you can even completely, or for most part, get rid of your classes. And if you keep this close to each other, you have a very powerful way of creating types and interfaces that help you keep your codes very safe, type safe and secure, whilst also being a lot more extensible. Like if we change to-do ID to be a number now again, because we don't want to get rid of the UID, so we want a nice auto-assigned number, then we only change it in the to-do, or in the to-do ID even, to be correct. And everywhere else that just listens to the interface basically says, all right, it's a number now. We don't care. The only part where you might run into problems if you're assigning the ID yourself in the front end, where you were assigning strings earlier and casting them as a to-do ID, that might hurt, and it will give you compile errors when that's a number now. So that's basically where we're at right now. There's more examples in the GitHub repo under the experiments.ts, and that's on github.com/Bjorn/ngAir193. Quick conclusion. Yeah.
Can you go back 2 slides real quick to that code?
Sure. Yeah, sure.
Couple things. What is the pick? Can you explain that?
Yeah, pick is a TypeScript function. It's a TypeScript compiler function. So basically, it will take an interface, I think, but it might also take classes or other types. But you basically feed it a base, in this case, the to-do interface. And with the comma, where you separate to your second part of the function, you give it a union of the, and it actually helps you with IntelliSense here. It actually helps you with the completion. You can pick from that interface that you feed it. You can pick the items, the values, or the variables basically that you want. And it will create in the new to-do a type based off to-do where it only has these selected variables that you want. So,
cool. That's interesting.
So that's what it does, yeah.
Thank you. And then the other question we want to do is, can you then explain that top line just a little bit more, one more time?
Yeah, sure.
The string ampersand is doing sort of there.
Yeah. So basically, we're creating a new type, and we're assigning it to a string, which is the base of the string. But we're making it unique. It's not only a string; it also has an anonymous. Well, it's technically an object. And again, it doesn't matter if it says to-do ID. You can have it say your dog's name and your cat's name, for instance. It doesn't matter as long as it's unique. Because what the type that you get is technically a string, but it has this anonymous union that you just give it. When TypeScript compiler goes around and checks your objects, and if there's a regular string, it doesn't have that secret anonymized object behind it. So when it compares the two, it says this one's a string and this one is a string that has something that you don't, and it will say these are not the same. You can't use these at this spot. So this is just a little trick to make your strings more unique. And there's even a more advanced one that I'll quickly put in the experiment if I have time. It's by the same colleague that came up with this one. So we can even make it more strict than this, but this definitely works for most cases if you just want to have a unique way. So you could basically do it with all your types, with your unique IDs, but you could also do it with, if there's something special about the title that you're using your to-do, you could have a to-do title, which is a certain type of string. And if you try to feed a function something that only expects to-do titles that isn't a to-do title, it will give you compile errors, which is exactly what you want. So it's basically a way of making a type more unique and clash with regular strings or other types that you've created. Hope that answers your question there.
But still keeping that type like a primitive type, like a string, right?
Yes, exactly. The good thing about types and interfaces is that after compile time, there's no artifact of this in your runtime. So your compiled code has no traces of this except for the construction of the object that you do at the bottom. All the rest is gone, and that makes it a little lighter and makes it maybe a little harder to debug if your compiler's okay with it. So we'll give you that.
Bjorn, John wants to know, how does it handle property name changes?
How does it what?
Magic strings. How does it handle property name changes?
Property name changes, as in if I change the name of the to-do ID.
No, I think it's referring to pick, right? That the
like that. Yeah. Well, if I change the title to be the name in my interface, then I'll get a compile error that it can't find title on the interface of to-do. So you'll get compile errors when you change things. So yeah. But if you change the title from a string to be a number, then it'll just assume that everything that you use title is now a number. Not a problem.
I think that's always one of the things that like you hit that point in TypeScript where you're like, whoa, did it just do that? Like this ability to, you can actually work with strings in certain places and it'll identify typing based off of those string names and places. It's pretty cool.
I really, really have come to love TypeScript for my daily job. I don't start a new project without TypeScript, honestly.
I think I speak for all of us when I say, Justin, can we have Bjorn back for another episode because this hour was too short.
Yeah, for sure.
Shall I quickly summarize then? So where were we? We were here, yeah. So quickly resuming or summarizing, classes are good when you use them with a very specific scope. Interfaces rule for any external data, but be type safe as well. And consider using additional TypeScript options. I will swear to you, if you take an afternoon out of your day, if you have that, to just play around with the TypeScript playground and just look at all the insane advanced functions they have, you'll have a good time and maybe learn a thing or two. So let the compiler help you without making it too hard on yourself. And that was all I have. Thank you so much.
Awesome. Very cool. Very cool. That's a lot of stuff to digest, right? And a lot of cool new little things in there as well for our viewers. Very cool.
I hope I was able to bring something new there. Yeah.
For sure. I mean, yeah, these are these things that we get into, right? As we start adding those features and start expanding and growing our apps and scaling our apps that we run into. Okay, how do we solve this thing? What's the best approach? And it's always challenging to take these concepts, right? And it's like you want to know these things ahead of time. So when you go to architect, even the little things that like you're putting the foundation in place, right? And so like these approaches to doing classes versus interfaces and types and stuff, it's great to have this kind of knowledge before you write your first lines of code, so you can kind of have an idea of how can I lay that foundation for a successful future. Absolutely. I wish I had known about the classes biting me in the future when I started on the first project. If we had known that would come to haunt us so badly, we would have instantly done it differently, thought it out more.
Well, now everybody in the chat wants an episode for advanced TypeScript. I want to know what Austin McDaniel thinks of all this. That's the real test.
You just like poking the bear.
I know.
I'm sitting here being good, being quiet, and
You learned something new today, Austin. That's a high bar there. No, we already knew it. Sorry, Bjorn.
I agree. I think we should definitely have an advanced TypeScript. There's a lot of things like pick and omit and unions and conditional types. That we could just write a whole book about.
We could totally go out with that.
And I'm volunteering Bjorn for this.
Well, I was also going to say that we also got James Henry out there that's been putting.
I was going to say that.
If he's listening or watching, we really would love to have him on here. And
can we get James Henry on the same episode as Bjorn?
Yeah, both come on.
Yes.
That'll be super, super interesting and educational.
Yeah, let's do it.
Let's the top of the hour. Let's get to picks. Unless there's any last things we want to add on here. Anybody have any final say? Or are we good? Silence. We're good. All right, let's do some picks. Who's got picks? Raise your hand. All right, we got 1, 2. Okay, so we're gonna start with Bonnie. Bonnie, go for it. I
have to say, this was not the pick that I started out with, but I'm obsessed with Bjorn's whole setup. So my pick is going to be the OBS thing that this is what he's using to do like the swipes and all the. I have to level up my my online panelist game now that I've.
Do you have like a link to that or something? To this?
It's Open Broadcaster software. I'm going to send you a link right now.
Thank you.
It's very cool, Bjorn. I want to be cool like you when I grow up.
Thank you. I can help you be cool if you want.
Yes, please.
All right. Any other picks, Bonnie?
No.
Okay. Austin? Bjorn, we let our guests go last on our picks because they get to wrap it up and be the star. So just FYI. So
that way they can't steal our picks, Bjorn.
That's not why. We want them to have the spotlight. All right, Austin, what's going on? What's your pick?
TypeScript 3.3.
What's fascinating about TypeScript 3.3? Anything other than
they changed the number, so that's pretty interesting.
Oh my god.
There we go.
That's good stuff already.
You're the worst.
Right.
I want to keep it secretive so the viewers will just want to go out and mysterious
and root about on the internet for what's new in TypeScript.
Awesome. He's got his entertainment card. He's playing that, right? Just tease and let people find out on their own.
Hey, Justin, can we slide in Chaos Monster's pick?
Oh yeah, what was his pick?
Chaos Monster is a friend of ours, and we love him, so we're going to pretend he's here. He wants us to do a shout out for Global Diversity CFP Day on the 2nd of March.
Awesome. Are we going to get a link for that? Put that out in the tweets?
Yes, Chaos Monster is going to tweet that for us.
Okay, we'll retweet it.
Perfect.
All right, Alyssa, do you have any picks?
Yeah, I discovered it yesterday from a friend, and it's 100 Days of CSS Challenge, and it's literally 100 days CSS.com. And so it's just like these challenges daily that roll out, and people post their pens, like how they solved them. And there's some JavaScript in some of them, but it's mainly CSS. And I think most of them can be done with all CSS, but I do see some cheaters using JavaScript. Anyways, but no, it's really fun to level up your CSS skills and compare yourself to other people, I think. So definitely shout out to that website I found.
Awesome. Yeah, you shared that the other day. I saw that. I want to check that out. Okay, I'm going with a gaming pick today, and it's Apex Legends. Oh
my gosh, you too. You too.
Come on, there we got to play. And our guests may know a little bit about that as well. A little bit about some gaming logic, but
it's great. Yeah.
Yeah.
It's
so I'm Fortnite though, guys.
What's up?
I said our guest does not like Fortnite.
Might not make a couple of friends with that, but hey.
Well, we did like you, Bjorn.
Let's get to our guest picks, Bjorn.
Yeah, so I have two. Firstly, the Angular Connect 2019 announcement was tweeted, I think today, but it might have been yesterday. I went to Angular Connect last year, and it was amazing. Definitely check it out. And I saw they also announced their CFP, so maybe I'll go, bite at that. I don't know. We'll see. And the other one that I have is ldjam.com. I'm not sure if a lot of people know it, but it's for the game enthusiast under us. It's 3 times a year competition and basically fun weekend for everyone around the world to build a game in 48 hours. It's a challenge, and it's super fun. I do it at least once a year for the last 4 or 5 years, and I usually stream everything, and it's just a blast. I would highly recommend everybody checking it out.
Very cool.
You're a blast.
Oh, you're a blast.
All right. Well, Bjorn, thanks so much for coming on, sharing your time, and sharing this content with us. We really, really appreciate it. Thank you.
Thanks for having me. It was a lot of fun to do. Hope you have me again.
For sure. For sure. All right. That's a wrap. Have a good one. We'll catch you next time. Later.
Have a great day, everyone.